Let's take a ball here, and throw it from some height. Throw it horizontally with a speed of say 30 meters per second. That's quite a big speed. The ball then falls. Okay, so it goes starts off horizontally, but it will start falling because of its weight. So it falls and it falls and it falls. Now suppose that after after some time, let's say after 4 seconds. Okay. After 4 seconds, let's say this ball now has a direction. Show this. No. This way. Say it has a certain direction, pointing this way. Let's say the direction to the horizontal is 53 degrees. 53 degrees. Okay. And let's say the speed at this time is 50 meters per second. The problem now is we want to find the acceleration. Okay. We want to find the acceleration. Now we know that the acceleration is given by the final velocity minus the initial velocity divided by the time taken. But things get a little bit complicated here because the motion is not along a straight line, so we can't just use numbers for the velocity. We must actually think about the vectors directly. So that's the vector u for the initial velocity, and that's the vector v for the final velocity. So these are all vectors actually. These are all vectors. So u is a vector, v is a vector, acceleration is a vector, time is not a vector, time is just a number. So according to this equation, as always, when we find acceleration, we must first find the change in velocity, v minus the u. We must take this vector and subtract that vector. So let's try and do that. How shall we do that? Right, let's use the triangle law of addition. Move the two vectors until their tails touch each other. So right. So this is the initial velocity, horizontal u, and that's the final velocity v. Right. Okay, so that's u and that's v. There we are. And to find the difference, let's say v vector minus the u vector, we must join the two vectors together, join the tips of the two vectors together. Okay, and the answer would be a vector pointing from u to v. Alright, from u to v. Alright, always the subtracted vector to the subtracting vector. So that's the change. Now we can do this. We have seen a few ways of doing this, but now if I just think about doing it by geometry, say by actually taking out our ruler and projector and measuring this out and drawing a picture, I can imagine maybe drawing a horizontal line for U, say with a length of 3 centimeters. Okay, say for the 30 meter per second. So I imagine that maybe I'll take 1 cm to represent 10 meter per second. So for 30 meters per second, I might draw 3 cm, and for the vector v, I have 50 meters per second. So I'm going to draw a line of 5 cm long at this angle of 35 degrees. Okay, so I have an angle here of 53 degrees, sorry. 53 degrees. I can measure that out with a protractor. And once we've done that, we can then use our ruler to measure this the length. Measure the length of v minus u, and we will find that this length is actually very close to 4 centimeters. And if we use a protractor to measure this angle, we'll find that it's actually very close to 90 degrees. Okay, you can try it out. So using this scale, right, since we have 1 cm representing 10 meters per second, the 4 cm here would therefore represent 40 meters per second. So now we have our answer. V minus u is actually a vector with a length of magnitude of 40 meters per second, and it is 90 degrees to the horizontal vector u, which means that it is vertical. All right, it's 40 meters per second, and it is vertical. So we now have a description for v minus u. We have an answer for v minus u, and we can kind of understand why it's vertical, because the ball falls under, let's see, the ball falls under gravity, under its own weight, which is vertical. So this weight causes a vertical change in the velocity. That seems logical enough. So now let's go back to our acceleration. What is our acceleration then? We have seen what v minus u is. Okay, it's 40 meters per second. But according to the acceleration formula, we have to divide by the time t. Well, how do we divide a vector by t, which is 4 seconds? How do we divide a vector? Well, the way to divide a vector by a number is to just divide the magnitude, the length of the vector. All right, but we keep the direction. Okay, so what it means is this. It means that since v minus u is 40 meters per second, I should take 40 meters per second, okay, 40 meters per second, and divide it by t, which is 4 seconds, okay, and then I get an answer, right? That's 10 meters per second squared, and I'll keep the direction of the answer unchanged, because the answer is supposed to be a vector as well. So since the vector is, since v minus u is vertical, I'm going to say that this answer, when I divide v minus u by time, the answer is in the same direction. All right, the vector answer is in the same direction. So therefore, the answer for the acceleration is 10 meters per second squared in the vertical direction. Okay, and this is actually the acceleration due to gravity. Right? Later on, we'll learn that we usually call it g. So there we are.